Welcome to the project demonstration of solar wind grid based charging station for electrical vehicle. So here the main application of this project is with help of renewable sources like solar and wind, we are going to charge electrical vehicles. For that we are going to design this charging station. So here the charging station will provide us the required voltage. So in our project we are demonstrating it for around 55 to 65 volts generation, which is sufficient to charge a battery of 48 to 55 volts. So that is a generation part of this project that is mainly done with the help of the inverting circuits. Why? Because the renewable sources like solar and wind can generate up to maximum of 12 volts, and the generated voltage is charging into this battery pack. We are using 12 volts 2 amp battery pack, but the required voltages for our electrical vehicles is minimum of 48, and then next level is 55 and 60 and 90, like that the voltage will be based on the battery packs inside the electrical vehicle. So for that minimum requirement is 48 volts. For that purpose what we are going to do is 12 volts DC will be converted into the 12 volts of AC initially with the help of this HVS circuits. So this HVS will do the inverting operation, which is used to invert the DC 12 volts of 2 amps of current will be done to the AC 12 volts of 2 amp of current, and that will be again step up to the required voltage with the help of this step up transformer. This is 12 volts AC to 230 volts of AC, and based on the load here we kept, based on the rating of this particular load, the system will provide us the voltage that to in a AC. But as we discussed, electrical vehicle consists of a DC batteries, means energy can be stored in only DC batteries, and for that purpose we need to convert the AC signal, means AC voltage which is coming out from this step up transformer to the DC with the help of this rectification and filtration. So after this we will get the DC. Based on the load capacity we are going to keep here, that will decide the output voltage. Means when we increase the load, the voltage will be decreases to 48. When we decrease the load, the output voltage will be increased up to 60-65 volts. So that is the main application of this project. For that mainly we are using the sources like solar and wind as of now, and storage purpose battery pack, and this is the charging circuits. And for inverting purpose we are making use of a PIC microcontroller and HV circuits, step up transformer, load, again AC to DC, and a measuring unit with multimeter. So these are the major components, and this is the grid to charging of the battery pack whenever there is no power generation section is available from this renewable sources. Okay, and coming to the ratings, so we are using 12 volt 5 watt solar panel and 12 volt 20 watts of DC generator, and here the ratings is 1000 rpm dynamo we are going to use here. The purpose of the solar panel thing, but whenever we are rotating this turbine, wind turbine, at 1000 rotations per minute, then it can generate up to 14.5 volts, and that is sufficient to charge our 12 volt battery pack. And coming to this charging circuits, there we can see the three sections are same. So first section consists of rectification, same as 3, filtration, and a resistor for LED current limiting purpose, and 2 diodes. We can see that the 2 diodes purpose is they are acting as a unidirectional current flow. Means whenever the battery is fully charged, then it will become the high potential. The same time whenever it is going to be the low potential if no sunlight or no wind input to this sources, then the power will flow from high potential to the low potential, then these sources may get damaged. In order to protect that, we are keeping 2 diodes which is acting as a unidirectional current flow. Means the current will be allowed from sources either from the grid or wind or solar panel, and then to the battery pack. It will block the current flow from the battery to the sources. And here you can see this is the rectifier. So DB107 is IC version of rectifier. So whenever we are providing a AC signal to this from the grid, so the grid nothing but 230 volts AC, and we are going to step down that 230 volts AC to 12 volts of AC, and that will be converted into the pulsating DC with help of rectifier and filtration to remove the pulses, so that we will get the pure DC of 12 volts, and that is will be given to the battery pack through this charging like unidirectional current flow diodes. But here we can see the same diodes were kept. So here the purpose of this IC, that's a DB107 IC, the purpose is to convert that like polarity corrector, means there we are going to rotate this wind turbine in clockwise direction. So when you rotate that in clockwise direction, then we can see the light indication. Same way in counterclockwise also we are going to get the voltage. You can see over there, right? Okay. So you can see the power is generating from the right indication. We can see that whenever it is in counterclockwise also we are going to get the voltage. So means here the rectifier will act as a polarity corrector. So plus to minus, plus minus minus, or else plus to minus, minus to plus. So that the voltage is polarity will be changes when the direction of the dynamo is changes, because we are using the DC dynamo. That will be corrected with the help of this DB107 IC. Same from the solar panel also, but in the solar panel section, if we accidentally place this in reverse direction, then polarity will be changed. That will damage the battery pack. So that purpose only we are using the DB107 IC for a polarity corrector purpose whenever we are providing the DC inputs, but as a rectifier when we are providing the AC input. So that is the purpose of these diodes on the charging circuits. And whenever we are providing the lighting on this solar panel, then we can see the more lighting intensity coming from this charge indication from the respective charging circuits. Coming to the battery pack. So here we are using 12 volt 2 amp battery pack. As we discussed, it consists of 6 4 volt 1 amp batteries. In that 3 are in series, so we'll get 12 volt 1 amp, and these 3 are in series, so we'll get 12 volt 1 amp. These two are in parallel again, so that we'll get 12 volt 2 amp DC output. That is input to this HVS circuit. HVS circuit consists of 4 MOSFETs. When we are going to on and off the 2 MOSFETs alternatingly to get the alternating current. So that is nothing but AC. Means 12 volts DC will be converted to 12 volts AC with the help of this H bridge, which is acting as an inverting circuit along with our microcontroller motherboard, and that will be step up to the transformer again to the load. So this is all about the flow of the project along with output from the input. So let us see the demonstration. So if you want to charge a battery, as we have seen the wind and solar, if you want to charge a battery, they just on the power supply, then the grid LED will indicate it. So it will get fully charged in a duration of 5 hours with the help of either transformer or wind or solar panel. If we are providing the full current, full-fledged power from the 3 sources, then it will get fully charged in a duration of 1 hour only. So that is the charging time will be decreased, so that we can charge a battery in less time. And after that, this is a main on off switch. Okay, so when we on this, the light will be on and off 2 times, and you can see the low intensity is coming out from the bulb. So just we have connected this already. Just keep this in DC 200 volts. DC 200 volts. As already the capacitor charged previously, we have on that. Now slowly the capacitor is discharging. Right, when we on this. Right. Now slowly the voltage will reach us to the 70 volts, and slowly the required voltage will be comes down between 65 to 70 will be locked, as we have set the limit from the load to the respective voltage. Okay, so before demonstration we should keep the battery under full charge, so that we'll get the maximum voltage. If you are getting low voltage, that is indication of battery is discharged heavily. So that's before demonstration, keep the battery under full charge. When you have that, again the capacitor start discharging rapidly. Thank you.